So if you see here, like this is the code for adding two numbers. Okay. So here the first line of the code, like area, reset, code, read only. It means actually a section of the code what we are like having here is reset. Okay. I mean, it's like we are saying that like there is a section of the code that is called reset, which is read only. That is the meaning of that. Like area means actually, see, it is like we are specifying in the, so you in the initial first class we had seen there is a program memory and like there will be data memory. So in that program memory, we are saying there is an area that is reset, and that is type of code that is actually not a data type, it's a code, and it is read only. Read only means, uh, I mean, when once you deploy or once you deliver to the customer, so it shouldn't be editable, right? So that's why we make it read only. And the meaning of this entry is like from here onwards we start the code. I mean, in the C code you see, right, like main, we start with the main followed by code, right? So that is like entry, we start from here. LDR, I mean, this some of the instruction might be new, but like, I mean, it's I mean, like when we understand or like when we go through the code, I'll explain what exactly it does. Yeah, but because like specifically we haven't discussed something like LDR or STR or all this. So LDR means it loads the memory address of this label. I mean, whatever the address is there in the nums, okay, that will be loaded to R0. The data will be loaded to the value R0. Okay, so I mean, like this nums is something like somewhere we might have stored the data, that numbers. Like, see, actually, when we want to add two numbers, so usually, like how you do, I mean, we take it from the user, right? So scanf, like in the C program, if you remember. So in the C program, what we do, like we scanf and we get the data and we add those.
Yes, sir.
So now basically here we have to get from somewhere, right? So that's where I'm saying. So like this nums is the location. It is like the location in some memory. So those content, first what initially what I'm doing here, I'm not loading the values. I'm not loading the value. You see, is equals to nums means I'm loading the address of the nums to the R0. Address of the nums, not data of the nums. In the C program, you have seen the pointers, right? And here I'm pointing the address where my numbers are stored. That I'm passing. Okay.
Yes, sir.
So equals basically says that the value being loaded is address. So this equal represent address. Okay, it's not the value. Okay. And when I say in the square bracket R0, now what R0 contains? The address of
So
nums,
the
right?
address of nums, yeah.
Huh. So in C program, usually what we do, initially we put ampersand of some variable. That means address of that variable. And then if I want to access the content, I mention pointer, that star of that variable. It means the content of variable. So in the assembly, I'll put the square bracket of R0. It means whatever the content present in the R0, I will move into R1.
Yes, sir.
So, I mean, whatever the content present in the address. So, actually, see, R0 has the address of nums. So, whatever the value present in this nums, I will be moving into R1.
Got it, sir.
Okay. And here, what I'm doing in the to the R2, whatever the address plus fourth location. So, you have to think of this way actually. Okay. So, I have memory. So in nums, I have some data 1. Nums plus fourth location, I will have data 2. Okay. So first I will load this data from the memory to R1. I will load this data to R2. Okay. So now you have to tell me what is the meaning of this line.
Sir, R0 is holding the address of result of R1 and
Correct.
R2.
So now I am loading R0, the address of result. Address of result. Okay. But I haven't done anything. I just loaded the address of result. And this is our main state. What we did, we added R1. R1 has this data, data 1, which is nums. R2, that is nums plus 4, data 2. I'm adding R1 plus R2 and storing in R3.
Got it, sir.
And whatever the result I got it, right? So the final result, right? So what I'm doing, the register R3, I'm storing in location R0. Okay. So this R3 I am pushing into location R0. So somewhere here I might have a result location in the memory. So this R3 value I will push back into memory. Okay.
Yes, sir.
So here stop B stop. It means it is kind of infinite loop. I will keep I mean it's an infinite loop. I'll be halting at this point. I'll not proceed. But you might ask like what are like last 3 lines, right? So this is actually my data section. I'm defining nums. Okay. And I'm initializing. Okay, initializing with these 2 values. Okay.
So what's the full
And
form of DCD?
DCD, actually I have to check it one second. That basically reserves the memory. Full form I'll just define constant double word. Okay, define constant. I'm defining 2 constant. Right? It means define constant double word. Okay, so I'm basically double word means actually 60%. I'm defining these 2 words. Okay, and here again I'm saying area, memory,
So what's the last word? Define constant double
word,
word.
WRD.
Okay.
Finally, I'm actually, if you see here these lines, I made it as a reset, right? Area reset, where I'm storing the code. Finally, I'm defining area memory, that is for data. So I'm actually reserving the space for result of 4 bytes. Reserve space 4 bytes. Okay, this is for just for storing the memory result. It's straightforward, right?
Yes, sir. Yes, sir.
Hope you got it.
So it's actually pretty simple if we understand the logic.
Right. So next, actually, ARM is basically 32-bit, right? 32-bit. All the registers, instructions are 32-bit. But if somebody asks you to add 264-bit words, then how to do that? That we will see. Okay. First, I'll paste the entire code. So here, if you see, like initially, whatever we are defining in the table, right? So it means number one, I'm storing in R1 and R2 register. Okay. So you know that like R1 is 32-bit, R2 is 32-bit. So MSB is most significant bit, right? So if I want to store something like 0x 5A329644384932 6FAT. So 4444, that is 36, right? So this will store in R1, this will be stored in R2. Same way, second number which I want to add, it will be stored in R3 and R4. Finally, my result will be stored in R5 and R6. Clear? I hope this
Yes, sir.
arrangement you are clear. So, like from the previous explanation, can you tell me like what it does? This line.
So that line I don't have a clear idea about.
So here I am saying
The entry is the main function that I know, and the remaining are
right.
easy.
Here I am saying that this is I'm defining a code area, the code memory. So name I have mentioned it as a reset, and I'm saying it is read only. I mean, somebody tries to edit this, this doesn't allow. I mean, it's like this area what I am defining, that is read only. It cannot be edited. So entry is something like where main function will enter. So can you tell me here?
So here R0 is keeping the address of number 1,
Right.
which is R1 by R2.
Right. So now it is actually number 1. Now it will be loaded to R1, right, at this point from the memory.
Yes,
Correct?
sir.
And plus 4. Here I might have stored now number 1 plus 4, some data. So that data will be stored in R2. And number 2, I might have stored in some location. So that address loaded to R0. And now I am loading into R. And plus 4, I am loading into R. Finally, I am adding add yes. What is the meaning of add s actually? What happens if I just, what is the difference between add and add is?
So I forgot the use of S.
Basically it updates the status register, right? So I mean now since we are dealing with like two registers,
So
we
it
may
actually
need,
sets the flag, no, sir.
yes, the status flag, status register.
So then what
So
is at C?
that is add with carry, right? I mean that is add with comparison. That is a comparison operation. So we had seen that like
Okay.
various conditional operations, correct?
Yes, sir.
Add C, basically CC, add CC. It means carry flag clear, carry flag set, like CS. Add C is not there. Add CS is there. Add CC is there, right? Add MI, PL, the conditional execution flags, correct?
Yes, sir.
Yeah. So here, see, since we are actually, I mean, now if I see this arrangement, if I want to add another number, R2 plus R4 I will add. Then since it is a 64-bit, I may have to pass the carry here, right?
Yes, sir.
Correct? So this has to be treated as a single bit. So for instance, like 55 plus 68, if we are adding, so 5 plus 8, 13, one carry you have to pass. So here also, since it is like I'm using two different register, I may have to pass the carry. That is why I'm using add. Here you can see somewhere, yeah, at this point, right? Add S sample. Okay. So I mentioned like add with CC is actually carry clear, but here add with ADC, it means add with carry. Add with carry. So whatever the carry, if like whenever I'm adding R2 plus R4, see here, what I'm doing, basically what I'm doing, like R2 plus R4 I'm doing, right? So I'm adding this. If the carry here, what I'm doing, R1 plus R5 plus whatever the carry I have forwarded here. So that I'm doing here. And result I have to store in R5. So that is why it is add with carry.
Got it, sir.
Okay. And result I have to store it in R0, correct?
R0.
But we know that like R0 is basically like, I mean, just a 4 byte. Right? So, but our result is actually 8 byte, right? So R5 I have to store in R0 and plus 4, then the result I have to store in R6.
So
Got it, right?
SWIS?
Yes, that I will explain. So this actually, I mean, right now we haven't discussed this SWI, but it is basically, I mean, in the going forward we have the discussion. It is a software interrupt. Software interrupt. In the sense, so whenever the program ends, it may actually like reach into some undefined pointers, right? So this basically, you may see that like whenever you run certain program, once the execution is done, that a program window will be closed, right? So SWIS ampersand 11, I'm saying close the or like end the program gracefully. Okay, it is to terminate the program or stop the program. Okay, so it means like, see, we are doing so many pointers and like somewhere the program pointer might have reached. So finally gracefully we are bringing it to our end of the program. Okay, that means actually you can note down the functionality. Software interrupt, SWI means software interrupt. Ampersand 11 means terminate the program gracefully. This means terminate the program gracefully.
Yeah, sir.
And stop be stop, previously also we had, basically we will be keep looping here itself. Okay, and here I'm defining those two numbers, number 1, number 2, and finally in the area I'm allocating 8 bytes of memory to store the result. Hope this is clear to you.
Yes, sir.
Next is the program to add first 5 numbers. Okay, in the sense like 1 2 3 4 till 5. Okay, 1 to 5. So first what it does, I mean, many of the things like common to previous
So it
programs.
defines the area of code.
Yes. Next is like main, like we
And
are
then the
entering into
main
the code.
function.
Yes. What are
Yes.
all the two things? Other two things.
So
Move
it
R0.
moves the R0 to, so 0 bit to R0, no, sir.
Value 0. Actually, hash
A
0
value 0,
immediately.
yeah.
Value 0. Right? R0, R1 is
So
updated.
what's the function used for? Continue.
Yes. So this continuous is just a label. Okay, label in the sense, this is you are defining. So I can mention like instead of continue, I can say like maybe str. That is my starting point. Okay, so something like that. So this is the continuous is a loop. Okay, loop label. So here you might have seen while some condition you will be looping, right? So you have to, so once this code is reached the end, then you have to loop it to this point, right? For that I am marking here with the name label. So this continuously label, and it's a user defined anything. It can be like, you can just mention abc like this. So this is some point you can see. I mean, when you understand the whole code, you will get to know why we have put it. Okay, so let me assume this is a label. What is the use? I'll come to this point like by continuing the program. Okay, so now add r1 r1 r0. What will happen here? Can you tell me?
So it will add a value of R0 and R1 and store it as the new value of R1.
Yes, what will be the in the first loop, first case? Now for the time being, I have moved r0 and r1 with the value 0. So now what will be the value now?
So R1.
Value I will say. R1, the result is in R1, but what will be the value of R1? Whether it is
So
1,
0,
2,
0,
3.
0, 1.
No, it is 0, right? What R0 contains? 0. R1 contains 0. R1 plus R0, that is 0 plus 0. R1 also 0
Oh,
now,
yeah.
correct?
Yeah, so yeah.
Yes. Now what I am doing, add R0, R0, comma hash 1. That means I am adding 1 to it. So now R0 will become,
The
it means
value of 1.
R0 plus 1. No, not 1. I'm adding, so add R0, R0, 1 means I'm adding, it is actually, I'm storing the result in R0. What I'm storing, R0 plus hash 1 means exactly 1, right? So R0 initially it is, here at this point it is 0. 0 plus 1, it became 1, correct?
Yes, sir.
Got it, na?
So next is the compare
Yes. So here
function.
I'm comparing whether R0 is 5.
So it's
Whether R0 is
false.
5? False.
No.
Correct. It is false. Then what is the meaning of BNE?
So it's a new function.
Yes. It is
So
actually,
binary negation.
no. It is branch if not equal. So here it is not equal, correct?
Yes, sir.
So then it will, here it will compare if not equal, then jump into continue. So it will again jump into continue. Program will jump into continue. It will not come to stop. So now what is R1? Previously it was 0 only, correct?
Yes, sir.
Now it
So
will
R0
become,
is 1.
yes, R0 is 1. So 0 plus 1. Now R1 also, you can just, first it was R1 was 0. R0 is 1. Now at this point, since R0 is 1, R0 plus R1. Now R1 will become 1, correct?
Yes, sir.
Here in this line, add R0 to 1, correct? Add R0 plus 1. What will happen? Now R0 will become 2, correct?
Yes, sir.
Yes. Now, whether R0 is 5?
So no, because it's 2.
Correct. So again it will loop. So now R1 will become R0 plus R1. R1 was 1. So it will become 3. And in the here it will R0 will become 3. Correct?
So there's like 2 more loops done.
Yes. So again 2 more loop will go. Here R1 will become 3 plus 3, 6. R0 will become 4. And finally R1 will become 10 and R0 will become 5. And here when it is 5, so this condition will not be satisfied. Then it will be stopped. Clear?
Yes, sir.
Okay. Maybe maybe shall we discuss one more program and end the session?
Yes, sir.
So you have some more time for the exam, right? It's like not immediately you have
So it's on 9th of August, next internal.
final exam or internal. For the
So
internal,
no, final exam is on 13th October.
oh, okay, okay. So for internal, whether we have covered the topics or anything.
Sir, internal syllabus, can I send it by tomorrow? It's like
Sure,
sir
sure.
hasn't told us yet, so.
Okay, but maybe like rough syllabus you can share it to me, so we can check
Yes,
so
so
that
this is
like we
actually
can.
unit 1, so it's not going to be there.
Okay, okay, okay. So maybe you can share the internal syllabus also, so that like we can start discussing on that as well.
Yeah, so can we discuss the internal syllabus from tomorrow?
Sure, sure, sure. You can
Yes.
just forward that, and lab manual also you can forward.
Yes, sir.
Okay. And maybe like once we complete that internal syllabus, then we can come back to you, right?
Yes, sir.
Yeah. So you have to tell me here what will happen. So many 2 3 programs we have discussed. So I mean, like I'll tell the objective of this program. It is to add n 32 numbers. Okay, n. It can be anything. So based on the user input, n can be 5, n can be 6, n can be 10. Okay. Yeah. Now you have to explain. I'll just listen.
Yes, sir. So R0 holds the address of the inputs and R1
Correct.
holds the address of all the outputs. And in
Correct.
R3, the value of 0 is, placed, and in R4, it's the same, like value of 0. And so it's like the address of R0 is placed in R2, and R4 and R2
Now,
are added.
the
That is
content
like,
of R0, content of R0. I mean,
so
whatever the
it's the same, so the value of 0.
no. See, actually R0. So inputs is the so initially I am loading just address of this R0, right? Address where it is located. Then
Yes,
here,
sir.
when I put in the square bracket, I'm actually loading the content itself. Okay, this address
So
may
the
be 0x.
contents is 0, no? So like the value of.
It need not be 0. Whatever the value is stored here, it will be loaded. So when I put in the square bracket, that value will be loaded. Not here. This is it is
Yes, sir.
here. It can store some value also. It may be like 564. Any value it might be stored. That value I am loading
Okay,
into
sir.
R.
Yes, and then R4 and R2 are added. That is, R4 contains value of 0 and R2 contains contents of R0. And R0 is later given the value of value of 4, and R3 is given the value of 1. And R3 is compared if it contains the value of 3. So R3 doesn't contain 3, so there's going to be a while loop until R3 contains 3.
Correct. So
And
basically,
R4 contains.
here this is a loop actually. It will be keep till
Yes, sir.
R3 becomes 3. It will be keep adding. Okay.
So, and R4 will contain the contents of R1. R1 contains like so. So R1 contains just the address of outputs.
So R1 basically, if you see here, address of output. So here, what I am doing, whatever the content stored in R4, like R4 is basically result, right?
Yes, sir.
See, I am keep adding. So the result will be moved into location R1. So that is at the outputs. I am loading there. If you see here,
Okay, sir.
like so here three values, right? Why it is three? The loop is why it is three because I have three values stored, right? What is DCD?
So
Yes, ma'am.
define constant double word.
Right, very good. So basically these three value we are defining, so it is keep adding that three values. Okay. So then
Yes, sir.
finally here I am defining four value, four result, 4 bytes of memory for storing the results.
Output. Yes, sir.
Right.
Sir, can you please scroll up to show how the while loop is done? I didn't write it down.
Here,
Yeah, so that part, like where R1
see here,
is,
actually, I'm comparing, right? So basically, this while condition controlled by this R0. Till this R0 becomes 5, I'm looping, right? Comparing. And if you see
yes, sir.
here, I'm adding R0 plus 1. So it is like, you can think like this. While I less than 5, I'll be running this code, right? So I'm doing I plus plus. That means I plus 1, right? So R0 plus 1. So when R0 becomes 5, I'm just exiting this.
Yes, sir.
Okay.
Got it, sir.
Okay. So next class, we will see some division, multiplication, logical instruction.
Yes, sir.
And you can share me that lab program and like the syllabus for the next. So if you have that
Yes,
notes
sir.
also, you can share to me.
So Note sir didn't send anything. He actually sends like 3 days or like 5 days before.
Okay. 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 But you can share me the topics. We can cover that. Like
Yes, sir.
once
I'll
he share
send
the
it.
notes with respect to that, we can discuss again. Okay.
Okay, sir.
Okay. Thank you.
Thank you, sir.